This is Physics 2211 Lab 5. Choose Your Own Adventure by me, Adil Abdu. In this lab, we will be analyzing a collision between two tennis balls with the same mass, as seen in this picture on the right. Based off the final velocities of the two balls following the collision, we will determine whether this was an elastic or inelastic collision. To help find this velocity, I will be using the tracker application. Alright, for our results preview really quick. A quick little preview shows that two of our values do not equal each other where we would expect them to. We're going to get more into that later. So really quick, just to reiterate, elastic versus inelastic collisions. An elastic collision is a case where energy is conserved. There's no momentum loss according to the momentum principle, while inelastic is where kinetic energy is not conserved. So here are some relevant physics principles for our lab. The first one is conservation of momentum, seen right here on the top. So it states that the mass, or the momentum of the first object plus the momentum of the second object with initial velocities for each should equal the mass of the first, or the momentum of the first object plus the momentum of the second object with their final velocities. The second equation we have here is total kinetic energy before is equal to total kinetic energy after, which is conservation of energy. One thing that is missing from this formula that we're done by the surroundings, which we would normally add in right here. So this states that the kinetic energy plus kinetic energy of object 2 at the initial state plus work done by the surroundings is equal to kinetic energy of object 1 plus kinetic energy of object 2 at their final state. So here's just a quick showing of the tracker application I use to measure the movements of the balls. So we have the X and Y axis here just to define our movements, and we have each time step for both balls right here with a ruler to show the distance that's traveled by both of them. So here's the lab experiment, right? Our tennis in their collision. Tennis ball that with the initial velocity, after it has a collision with the other tennis ball, it does have a slight velocity still, and it doesn't go to non-zero, or it doesn't go to zero. So here are the calculations we would use given the conservation of momentum principle. So we have the mass 1 is equal to mass 2 of the tennis balls. They're both 0.057 kilograms. Seen right. We have V final is right after the collision, and V initial is right before the collision, okay? So we know that the second tennis ball is not moving before the collision, and the first one is. So we have M1 V1I is equal to M1 V1F plus M2 V2F. We see that M1 and M2 are equal to each other, and so they cancel out on everything, and we're left with V1I is equal to V1F plus V2F. Here's a little diagram showing this collision on the left. So we can see initial velocity here, zero velocity here for its initial for ball 2. Collision happens, non-zero velocities for both of them. So here are the tracker results. We can see that right here we have at about 0.4 seconds on both graphs, we see that the collision happens because ball 1's velocity shoots straight down as it's slowed and that energy is transferred to ball 2, and then ball 2's momentum shoots straight up as its energy is the energy from ball 1 is transferred to ball 2. Okay, so after data from tracker, we are given an initial velocity of 0.608 meters per second for ball 1, and a final velocity for ball 2 of 0.463 meters per second, and a final velocity for ball 2. Sorry, ball 1 was 0.463, ball 2 was 0.101 meters per second, and we plugged into the formula we had before, so V1I is equal to V1F plus V2F. But we see something interesting here. We see that 0.608 is not equal to 0.566. That's the sum of these two right here. So why could this be? We're going to look into that in the next slide. So as it turns out, this is not an inelastic collision, but rather an elastic collision. This is because the momentum is not conserved fully. All right, we're going to see why when we look at the energy principle on the next slide. So if we go back to our formula of the conservation of momentum, we see that momentum is conserved in cases where there are no external forces. In our case, there are external forces such as drag, friction, air resistance, which would cause there to be a change in the energy in the system because there's work done by the surroundings being anything that isn't on our system is just the two tennis balls. So that is what leads to our momentum final not being equal to our initial momentum. So our what if question is, in the context of the real world, are there ever any perfectly elastic collisions? Our background image here kind of gives us an answer in the case that there really are, because there's always forces acting on anything, on Earth at least. Right? There's also things such as friction and air resistance or drag that are always exerting forces. There's also things we can think about in cases where energy goes during a collision in a system. Things such as heat transfers or sound. That's energy loss that can't be conserved in the momentum principle. All right. Thank you for watching.